Welcome back to Maths in an Empty Classroom with me, Mr. Southern. This is part 2 of the lesson on friction, and in this video I'm going to be going through 2 examples to find acceleration of a particle that's experiencing frictional force. So here we are, we have a box with a mass of 3 kilograms. We are given that the coefficient of friction is 1/2, and we have a force of 18 newtons acting at an angle of 30 degrees to the horizontal. And what I'm going to do is find out the value of the acceleration. So what I'm first of all going to say is that the acceleration is going to be in this direction here. So that's what we're taking as the positive direction, and when any resolving we do is going to be in that direction horizontally. Now, forces acting on this system then, we have the weight, which is 3g. We have the normal reaction force, which we're going to label R, and because we've been told that there's a coefficient of friction, we're going to have a value of friction there which we'll label with a lowercase f. Now we also have to resolve this force which is acting at an angle. We need to do that both horizontally and vertically. So I'm going to draw in my component force lines horizontally and vertically. And I'm going to label the horizontal one as 18 cos 30, and the vertical one as 18 sine 30. Now that I've labelled all the forces and components, I'm ready to resolve. Now, the first thing that I need to do is to find out a value for friction. I'm going to do that by resolving vertically. Now, resolving vertically, this is an equilibrium, so total forces up are going to equal total forces down. So I have, going up, I have R plus 18 sine 30 is equal to 3g, which is the weight going down. Now remember, in maths we use g is 9.8. So what I'm just going to do now is 3 lots of 9 minus 18 sine 30, which gives me a normal reaction force of 20.4 newtons. Now that reaction force is less than the weight because this vertical force here is doing some of the job. So the floor doesn't have to resist with as much force to support this box. Now the purpose of finding out R was so that I could find out friction, and I'm going to use the fact that the maximum friction is equal to mu times R. Mu is 1/2, so I'm going to do 1/2 of 20.4 to get that my friction value is 10.2 newtons. And I'm just going to label that on the diagram here. So now I'm in a situation where I can resolve horizontally to find the acceleration of the particle. So, resolving horizontally using resultant force equals mass times acceleration. I've got this force here in the direction of motion, 18 cos 30, and the resistive force is that friction, which is 10.2. So I've got 18 cos 30 minus 10.2 is equal to the mass, which was 3, multiplied by the acceleration. So I'm just going to work out 18 cos 30 minus 10.2, which is 5.388. I can divide that by 3 to find the acceleration, and the acceleration to 3 significant figures comes out as 1.80 ns to negative 2. Okay, so that's example 1. Just moving down here, I've got example 2, and we're going to do the same thing. We've got we're going to try and find the acceleration. Now, with this one, we've got a little bit different. This 30 Newton force that's acting at an angle of 40 degrees is pushing down into the particle like this. That means that it's going to be moving the particle this way. So now we've got the scenario where the acceleration is going to the left. So I'm going to take left as being the positive direction in this case. Now friction will resist motion or intended motion. So if this force is trying to make the particle move this way, friction is going to be going this way. So I'll draw my friction arrow there, and I'll label that with a lowercase f. It's very important friction's going the opposite direction to motion. Other forces I've got acting on this system, well, I've got the weight, which is 2g, and I've got the normal reaction force, which I'm going to label r. I then just need to work out the components of this force here, which is going downwards at an angle of 40 degrees. Now, when I draw in my vertical component here, and my horizontal component, with the vertical component, it's very important that this is acting downwards. So it's pushing down into the ground, which is different to the previous one, which was pulling up. So this one is 30 sine 40. And this one here, which again is going this way, is going to the left, this one is 30 cos 40. So now that I've resolved all my forces into horizontal and vertical components, I can look to resolve vertically and horizontally to solve the problem. So the first thing that I'm going to look at doing is I'm going to resolve vertically. Now this time I've got to be a bit careful because it's still in equilibrium vertically. So total forces up is equal to total forces down. But this time the only force acting up is that normal reaction force R, because we've got this 30 sine 40 force which is acting downwards. And we've also got the weight, which is 2g. So I'm just going to use that to work out a numerical value for the normal reaction force, which is 38.88. So that reaction force is greater than the weight, and the reason for that is this force pushing down on the box is causing it to press harder on the ground, and the ground is having to react with a greater force to counteract that. So that's the reaction force. We use that to calculate the maximum value of friction using mu times by r. Now we're given here that mu is equal to 2/5. So the maximum that friction can be is going to be 2/5 multiplied by the normal reaction force, which comes out to 15.55 newtons, which I'll just label on my diagram. 15.55. Okay, now I'm in a position where I can resolve horizontally to find the acceleration of the particle. So, resolving horizontally, I'm using resultant force is equal to mass multiplied by acceleration. Now I resolve in the direction of motion, which is to the left, which means that left is positive. So this 30 cos 40 force is going to be my positive one. And my negative force going in the opposite direction is my frictional force, that 15.55 newtons. Now that's equal to the mass, which was 2, multiplied by the acceleration. So 30 cos 40 minus this one here comes out as 7.427, and dividing by 2 and rounding to 3 significant figures, I get that the acceleration is 3.71 meters per second. So just a quick summary of these two things then with regard to friction. The fact that we have this downward force acting here causing the box to be pressed down into the ground is increasing the amount of friction. It's always going to be mu multiplied by the reaction force, but because the reaction force got bigger, friction got greater. That's the opposite to what happened in the previous one, where because this force was acting upwards and was lifting the box, slightly reducing the amount of contact between the surface and the box, we had less friction going on there. So there we go. Thank you very much for watching.